All
All
right.
right, well, here's Randy Knight to bring us home on our first day of GroupBy. Thank you so much for being here, Randy. What, man, I feel like we have a little bit of a superstar to bring us home.
I know the presentation mode is backwards, so I need to.
Oh, all right. Well, can I talk about how great you are when you figure that
There
out?
we go.
All
Yeah,
right. So
go
Randy,
for it. Sorry.
Randy is Randy is a dear friend of mine. He's going to introduce himself. He's going to talk to you about who he is and what he does, but he has been a very close friend of mine for a number of years. He's a SQL Server master. He's one of the smartest people I know, and he's very, very active in the SQL Server community. And so it is just such a treat to have him on the DBA track. I fought for this moderator position so I could be here. I will not be here for when you end, so Josh can maybe bring it home, but I'm going to be here for most of it. And today, what are we talking about? All
All
the
right.
features.
Well,
Yeah.
this is a fun one. I'm calling it feature phobia, and it's over the last 10 years we've done hundreds of health checks on SQL Server environment, right? And there's just kind of a common set of things that people just aren't using, and there's some really good use cases for why we should be using them. And so that's what we're going to talk about, is just kind of a list of what some of those things are. This is totally unscientific. This is based upon Randy's experience looking at bunches of SQL servers, right? It's not, there's no control, there's no samples, but it's just, the things that I see. And so yeah, really demo heavy, and not a lot of depth on any one feature, right? Because we're going to talk about a bunch of stuff, right? But hopefully, give you some ideas on things that maybe you're not using, that would benefit you. So yeah, super excited. We ready to go?
Oh, so ready.
All right.
So ready.
So it's the last session of the day. So I'm sure you've seen these slides more than once, but the GroupBy code of conduct is definitely important, not just in GroupBy, but these kinds of things just in general. Always, grateful to our media sponsors. Having been one, I think it was last time around. So appreciate the the people who do that. So what's our agenda here? So the first thing that we're going to talk about is this concept of the SQL Server Common Programming Service, or Surface. This was implemented by Microsoft in SQL Server 2016 SP1. And the idea is that your code, your schema, your stored procedures, your database that you deploy should work regardless of the addition, right? So things like table and index partitioning, right, that used to only be enterprise edition features are now available in all editions. So you don't have to say, oh, well, are you on standard or enterprise? Well, we can't use that. And so moving more towards just scale being the real issue for enterprise versus standard rather than the feature set. And then we'll talk about a list. And again, this is Randy's list of things that I see or don't see that I think would benefit a lot more people if they were using them. And then I've got, basically 4 of these that I've got demos that we'll just kind of walk through and look at how they work and some use cases and how they would help you. And then maybe talk about some next steps. So Common Programming Surface Area. Again, this was introduced in SQL 2016 SP1 and without a lot of fanfare. Like there was a blog article about it. There's some documentation about it. I got a screenshot from that coming up, but it's not as well known. And I think that's maybe one of the reasons why people don't use some of these features. But the idea is that, how many of us have written code over the years that, if you're especially if you have an ISV or something like that, that you need to support multiple versions of SQL Server, and even within those versions, multiple editions, right? Great example of this, SQL Sentry. SolarWinds SQL Sentry has a component called the Scalability Pack that uses partitioning, among other things. And so it was an optional component for years, right? Because you had to have Enterprise Edition for it to work. Well, now it just implemented as part of the product because it will work on any version, right? So this is out of the announcement in the Microsoft Docs about SP1 2016, and kind of, you know, showing the difference of things that originally were not supported at RTM that as of SP1 were. And you can see it's a pretty good list, right? If you look at things like, you know, change data capture, column store indexes, table and index partitioning, in memory, all of these things you can use in just about every edition. Now, there are some caveats here, and if you go to the link and you look at the notes, it tends to be a function of, you know, like SQL Express change data capture. Well, you have to have SQL Server agent to use change data capture. So you can't very well do that on SQL Express, which doesn't have agent. And there's some things here, but by and large, if you're on a real version of SQL Server, and let's be honest, even web, most people don't think about, really what we're talking about is standard versus enterprise, right? And so the CPSA, Common Programming Surface Area, the idea there is that, you know, as a developer, or as I'm maintaining a code base, I should be able to use these features, whether it's standard or enterprise. And the true enterprise level features, you know, have to do with scale, right? How much memory, CPU can you access? And then, you know, things that are really DBA configuration level things, right? Things like resource governor or, you know, availability groups. In standard, you have basic availability groups. Well, availability groups, aside from the fact that, you know, you potentially may be using application intent read only, that's not really an issue in standard in your code, right? All right, so let's talk about a list of what some of these features are that we see that are you know, quite often not implemented, that, you know, there's some use cases that would benefit almost any database. So number one on my list, anybody who knows me who's you know, followed any of my sessions or things over the years knows that I'm on a mission to eradicate no-lock from the world. It's one of my pet peeves, and, you know, years ago, read uncommitted, dirty reads, no-lock, whatever you want to call it, kind of became the go fast button for concurrency issues in SQL Server. And since SQL Server 2005, we've had snapshot isolation, right? Which allows us to solve that problem in a much, much better way. You know, I'm of the opinion that almost every SQL Server database will benefit from snapshot isolation, and it's not going to cause problems. And there are some caveats there that we'll talk about as you know, we get into that demo. But this is one that's, you know, kind of a no-brainer. I was talking to a vendor not long ago about this and whether they supported RCSI, and that's the acronym for Read Committed Snapshot Isolation. And the response was, well, it's on our roadmap, but we haven't really gotten to testing that because it's a relatively new feature. 2005, and the comment that I didn't make that I wanted to make was, well, you know, this feature can get a driver's license in the United States. It's almost old enough to vote. Perhaps you should support it. So this is not new technology. And the other thing that I always tell people is that optimistic concurrency, which is what RCSI is an example of, is how other major DBMSs such as Oracle, DB2 have always worked, right? So that's always one of the follow-up questions. If it's a vendor like that, a vendor app, ISV, well, you know, does your application run on Oracle? Well, if it does, then you support RCSI. So that's number one. Number two, much newer feature introduced in SQL 2016, but one that I would say even today, probably 70% of the databases that we run across have not enabled Query Store. And Query Store is built in, it's free, and it gives you a bunch of really good data on your queries, on your execution plans, on all kinds of things. And so that's one of the ones that we're going to look at in the demos. The third one, data compression, whether it's row store based, page and row compression, or column store indexes, which, we now have the ability to use ColumnStore for an updatable column store index, right? So when ColumnStore first came out, it was very much a data warehouse thing. Read only, you disable your index, you load your data warehouse, you enable your column store index, and it's blazing fast. Well, in 2016, they gave us the ability to have what Microsoft calls it operational analytics using ColumnStore. And so we'll look at that, right? What are the benefits of compression and how it will more often than not improve performance. A lot of people hear compression and they think, oh, overhead, compress, decompress, whatever. But the thing to remember is that databases are IO bound generally, rather than CPU bound. So a few CPU ticks to store, 3, 4, 5 times as much data on the same data page. Now we're talking about less memory, less IO between CPU and memory. Forget about disk. That's one issue, right? But keep in mind that all of those data pages, even if it's all coming out of buffer cache, it's all coming, to and from your CPU using that bandwidth, right? The next one, partitioning. This is another one that used to be an enterprise only feature. And I think that's the primary reason why it's not used more. But there are some great use cases for partitioning for an OLTP database for almost any database. And I'm going to look at just one of them today. And that is the fact that you can truncate a partition. So think about purge processes, right? How many of us have these, multi-million or billion row tables that have grown forever? We know we need to purge data, but it's too darn expensive. Those batch-based delete operations, right? Well, if that data is partitioned by date is a pretty common way to partition data. You can truncate, you can say, okay, I'm done with 2016 data, truncate that partition, minimally logged. You're not going to blow up your transaction log. It's a great way to do that. That's just one benefit, right? Index maintenance is another one, right? Being able to, rebuild indexes a partition at a time rather than one big giant index, right? How many of us have tables that the database has gotten to the point where it's so big that we can no longer do index maintenance on it? I hear that often. So, all right. In-memory OLTP is now available, and in-memory has definitely some specific use cases, but it's another one that we rarely see used. Always encrypted, being able to, which is, sometimes when I bring up always encrypted, people talk about, there's confusion on what always encrypted is, primarily with TDE. TDE is encryption at rest, right? Your SQL Server data files are encrypted, kind of like a BitLocker thing at the database level. Always encrypted basically encrypts the data in specific columns. It goes to and from the client encrypted, and only the client can decrypt it, right? If you have the right key. Row level security, change data capture, change tracking. How many times have I seen really complicated stuff that people have built with their own triggers to kind of keep track of what's happening? And if you look at things like change data capture, change tracking, or even SQL Server audit, which is also on this list, used to be server audits were available in standard edition, and but database audits were enterprise. Well, now we can use all of those things, right? Dynamic data masking, right? And I mean, we could go on for days, right? But But these are all built-in SQL Server features that, you know, when we're out there looking at environments, doing things, we don't see used a lot, except for in very specific cases, right? You know, I can't tell you how many systems we see that are having, you know, IO issues, not CPU bound at all, and just data compression, page compression, right, would make a huge difference. So, like I said, this is going to be a demo heavy session, right? So we're really gonna, there's not a lot of slides here. We're gonna dig into this. And so we're gonna start with RCSI. So let's go there first. One of the things that I hope to accomplish here, and people give me a hard time because they feel like every session I ever do has this no-lock demo in it, but it's hopefully we'll scare you straight on why using dirty reads or no-lock, or you know, basically you're saying I really don't care if my data is correct. And so let's take a look. So I'm going to switch over to SQL Server Management Studio here, and we're going to start real simple. We're using for this one the AdventureWorks database. One of the things I do when I do demos for sessions like this is I try to use the Microsoft provided databases, AdventureWorks, Wide World Importers. You know, I probably got a copy of Pubs laying around somewhere that I could use for a demo. But so that it's easy to reproduce, right? And then you'll also find that, you know, I don't necessarily have references to them, but a lot of the scripts and things that I have are straight out of Microsoft documentation, right? There's nothing magic here, right? So the first thing that we're going to look at is we're going to query sys.databases and see the current state of RCSI and snapshot isolation in AdventureWorks. And so we can see RCSI is actually turned on. So I'm going to turn it back off, right? So we're in a completely default SQL Server install here, read committed, right? And we're going to actually set our transaction isolation to read committed to ensure that. And let's take a look at one row in the human resources department table, right? Group name, research and development, right? And I have this version store query because when we come back and do this with RCSI, we'll take a look at how that works. This is the place that when people have a concern about implementing RCSI, it's this. SQL Server maintains a version store in TempDB that is primarily used for RCSI. There are some other uses for it as well. But the way Snapshot works, the reason it's called Snapshot, is that as data is modified, SQL Server keeps a snapshot of that data in its, what I would call its committed state, right? So the whole concept of a dirty read is that you have data that's in flight in a transaction, it's been modified, and when I query that data, I get the modified version of the data, the unmodified version of the data, sometimes both, sometimes neither, right? so we kind of don't really know what we're going to get when we're using no lock, right? So what we'll do is look at a couple of DMV queries as we're doing this to see what the impact on TempDB is. TempDB definitely needs to be optimized on every SQL server, not just if you're using RCSI. You know, fast storage, you know, even in the cloud, you know, AWS and Azure both have the ability that you actually put TempDB on NVMe based SSD on host, right? So there's ways to make TempDB very fast. So we're not going to worry about those queries right now with the version store because we're not using the version store. All right, so we're going to begin an explicit transaction, and then we're going to just update the value of that department in that table. In this connection, of course, if I query that data, I get the new value, which is R&D. Remember that the That's the dirty value, I guess is the best way to put that. The committed version, or the valid version, is still research and development because I've not committed my transaction, right? I have an open transaction, right? Now let's go over here in read committed and let's try to query that row. What's going to happen? Well, anybody that's used SQL Server for more than a minute knows what's going to happen. This is called a block, right? In pessimistic concurrency, which is the default behavior in SQL Server, readers block writers, writers block readers, writers block writers. Everybody's blocking all over the place, right? And this query would sit here forever until I either commit or roll back this transaction, release my locks, and off we go. This is the most common concurrency issue we see, right? Is blocking or excessive blocking. So what do people typically do? Well, they go over here and they say, I'm going to use a dirty read. And I'm going to query that table. And you know what? I got the dirty value, but I can live with that because it's fast, right? What we're going to look at in a minute here is that it's not just about the dirty value. It's about the fact that I could have got both rows, neither row, one or the other row in my results. Without locking, I have no way of confirming that that data is correct, right? All right, now obviously, if I roll back or commit my transaction either way, then my read committed query works, right? Okay, everybody gets that. That's how SQL Server works. If you're a developer DBA, you've been doing this for a long time. What we're going to do now is we're going to go and enable our CSI on this database, which of course is going to kill the connections, and do the exact same thing again, right? We're back to the research and development, the long version of that name. We'll take a quick look at the version store just to see if there's no rows in there from this database and there's no space being used for this database, right? We will start our transaction, do our update. Everything up to this point is exactly the same as that we saw before, right? If we look at our version store, we have some data in there now, right? Because there's two versions of this row right now. There's one that hasn't been committed yet that says the group name is R&D. There's another that is the committed version that says it's research and development. Well, now if I go over to my other session, I haven't changed anything here. I'm in read committed. Everything, the only thing that's been changed is that the database has been set, RCSI is on. Execute my query, it comes back immediately with the committed version of that row, right? So RCSI is the easiest way to solve an awful lot of concurrency issues, right? Because, as I said, in the default behavior, pessimistic concurrency, readers can block writers, writers can block readers, writers block writers. Really, the only thing that doesn't block is readers blocking readers, right? With Snapshot, really the only locking that's taking place are write blocks. Writers block writers, and that's it. I was early on when Snapshot was still kind of new. I remember talking to a friend of mine who was a longtime Oracle DBA, written bunches of books for Oracle Press, and things like that, and talking about this. And he was kind of shocked that SQL Server didn't just work that way. And he said to me, he said, I'd go so far as to say there's no such thing as a read block in Oracle, right? That's just how it works. Okay, so that's our CSI. The other thing that I want to show you is what those dirty reads can do to you. So what I'm going to do, I'm actually going to switch this back so that we're seeing our dirty reads. Okay, and then let's go to this guy. I have a table here called I hate my data, in case you were wondering how I feel about dirty reads. It has 200,000 rows in it. This table is silly stupid. It has an identity column and it has a GUID column, and it has a clustered index on the GUID. And what we're going to be doing is updating those GUIDs like crazy, which is of course going to cause that data to move around and cause page splits. And page splits are where this problem that I'm going to illustrate come from. If I don't have locks, if I don't know where that data is, when I execute this query, and keep in mind that dirty reads, you know, one of the things I hear all the time is, oh, we've been told that we should always use no lock in reporting queries, right? Well, reporting queries have a tendency to be long running, expensive queries. They also have a tendency to do a lot of aggregations, and that's where this can become an even bigger problem. And so when you think about how SQL Server executes a query, it doesn't happen all at once, right? It's reading data, it's reading pages, getting the data, you know, locking the data, reading the data, releasing the lock, and kind of moving through your table as it does that. Well, with page splits, you've got data moving around. So you have a row that used to be on page 10 and it got moved to page 57. Well, maybe I read it when I read row page 10, and I'm going to read it again when I read page 57. So now I'm going to count that, I'm going to include that row twice in my result set. The opposite can be true, right? The data moved out of the scope of the pages that I'm going to read because there wasn't any data on those pages when I started executing my query. So what we're going to do here, I've got a separate connection here that we're just going to, in a loop, in read committed, start updating every GUID in that table like crazy. This is totally artificial. Its only purpose in life is to generate page splits. And then we're going to go back over here and we're just going to go into another loop and we're just going to count the rows in this table. We know the table has 200,000 rows in it. All we're doing to it is updating, right? So we are not, you know, our row count shouldn't change, but what's happening here? If I look at my row counts, if they will start streaming, we are going to see that that's not true. I am in the correct database and I did turn off I swear I ran this right before this session. Let me double check. RCSI off. There's my updates. Updating data and one of the things that's happened is SQL Server gets better at this as the versions go on. Years ago, this demo would generate way more our CSI is off. I ran this moments before this session, I promise. Okay, well, what I was planning on showing you, these should be coming out with some of these with, you know, many more than 200,000 and many with less than. And why that's not working right now, I can't tell you. We are on the same instance, same database. I think Jeff must have come in here and fixed my GUIDs since he loves GUIDs so much. I'm just kidding. It's very strange. What happens if I just... It's actually acting like it's still in RCS, it's still in Snapshot, because that's what we would see in Snapshot, is that our 200,000 would be consistent. So I'm not going to waste any more time trying to troubleshoot that. That's a little bit odd. But ultimately what you can see is multiple versions of a row. One of the ways that you'll see this, look at that. Jeff made a comment. I've seen the demo in the past and can verify that what Randy says is true. So there you go. What I've seen quite often in production situations is that you get some really weird transient errors. Now, I mentioned reporting, where you're aggregating data, and if you start, getting multiple copies of the data or missing data, now your reports are wrong. But I've also seen primary key violation errors from app code, right? And you look at the code, and there's no possible way this thing, tried to, reuse a primary key or anything like that. And the way the code was written with no lock was the cause. And it's those problems can be really hard to track down because they're so intermittent, like transient, right? Like that could have been what's going on here, right? If we'd let it run long enough, maybe we would have seen something, right? That we usually this demo, it's pretty significant. But anyway, that's RCSI. So this is one. Now, for any of these things, keep in mind, no one's saying, hey, go back to your job and start turning all this stuff on, right? You need to understand, how it's going to impact your application. There are some absolute cases with RCSI that, I joke about it, that, the application is dependent on being broken, right? And what I mean by that is, we're using blocking to decide whether data is available to me, or just kind of different things like that. So obviously, but just be aware that it's something that, in my opinion, should be used a heck of a lot more than it currently is. Okay, the next thing that we're going to look at is partitioning, right? So partitioning gives us the ability to take a table, or really an index, right? All data in SQL Server is stored as indexes, clustered indexes. Now, heaps are an exception, but we don't like heaps, and you can't partition a heap anyway, right? So the clustered index is the data, right? And so partitioning allows me to split that data up across multiple partitions that can be on different file groups, on different volumes, whatever. They don't have to be, but they can be. And it allows me to do things like index maintenance on a partition by partition basis. And just, there can be some performance benefits to partitioning, depending upon the queries and how it's working. That's not really a primary purpose, but it's a manageability thing. If you've been around, large SQL Server databases, everybody has examples of, we can't do index maintenance. We can't rebuild indexes on this table ever because it just takes too long, even with online rebuilds, right? Well, this is a great way to do that. You can also manage it differently, right? If you're partitioned by date and most of that data is historical and it's not changing, there's no point in rebuilding indexes for those partitions, right? we're actually going to look at a use case that I think is a great use case for partitioning that a lot of people don't think about. And that's, as I mentioned earlier, managing log tables or purging data. So let's take a look at this. One of the things, and I'm going to go ahead and close these, that I always like to point out is that, ever since, whatever version we got this, every index is partitioned, right? When you get to the physical storage of an index, you have to look at sys.partitions, right? Many indexes, most indexes only have one partition, but it's still a partition, right? And so the first thing, I'm using the Wide World Importers database. This is the most recent demo database or sample database that Microsoft has provided. It's the one that, they have, there's some pretty good documentation out there too about the features that are implemented. And when you look at it, you can see that, right? You can see, temporal tables, right? Those are the guys with the little, the clocks and things like that. And so there are some tables in this database that are already partitioned. So the first thing we're going to look at is say, hey, let's take a look at, sys tables, sys indexes, sys partitions, and sys partition schemes, right? Anything that has any partition that exists in partition schemes by definition is a partition table, right? Or a partitioned index. So I'm just going to run that query and we can see there are two tables in this database that are already partitioned. And so we're just going to randomly choose to use the sales customer transactions table, right? This next query looks complex, but really it's just joining those same tables we already looked at, tables to indexes to partitions, partition schemes, partition functions, and our partition range values, right? So that we can, and this is one of those queries that's right out of the Microsoft documentation, and we give it a table name that we're interested in. I also have index type less than or equal to 1, meaning I only care about the clustered index, or it's not going to be a heap, right? So clustered index, the index ID will always be 1, right? So if I query that, we can see that this table right now has 5 partitions. The partition function is PF transaction date. We can see how many rows we have in each partition. And we can see the boundary value here, but they actually in this query even kind of break it out here to say, hey, this is anything before January 1st, 2014. This is January 1st, 2014 through, basically all of 2014, all of 2015, all of 2016, 2017 and higher, right? If we query that table and look at just the year portion of the transaction date, we'll get those exact same row counts, with the exception that, of course, in fact, let me run both of those queries together. With the exception that that last partition is large, right? Because this is a sample database. It hasn't had any new partitions added since 2017, right? So that's what we have there, right? So we can see, for example, like that in 2016, that partition says that it has 31,000 rows, 2016, 31,000 rows, right? So this is a partitioned table. The use case that I wanted to show you is this one. If I have aligned indexes, and so, when the way you partition a table is with a partition function and a partition scheme, the partition function determines how it's going to be partitioned. The partition scheme is the storage, I guess is the best way to put that. And we can look at those objects. But what I can do is I can say, okay, I have 27,000 rows in 2014 that I really don't need anymore. So I'm going to say, what partition number is that? That's partition number 2, truncate table, partition 2, rather than an expensive delete statement, now this is 27,000 rows, it's a demo database, right? But this could be millions of rows, right? And we've all had that experience that when you have a big table like that you need to purge data, you know, it's going to blow up your transaction logs, and then you do things like batching it. Or, you know, since Jeff is on, I feel like we should all advocate using, you know, a cursor to delete these rows one at a time, right? Jeff probably has steam coming out of his ears right now, but no, like you have to do these things, right? That, well, I can't delete them all at once in a set, so I'm going to delete 100,000 rows at a time or whatever. But deletes are expensive operations. Here I can just say truncate and specify the partition. And now if I look at my rows per year, 2014 is gone. That partition is empty, right? So this right here, there's a place for this use case for partitioning in almost every database, right? If there's not, it's going to be because you're not purging your data, and that, you know, that brings up its own set of problems, right? So lots of things to talk about with partitioning, but that's a use case that, you know, is a pretty straightforward one that makes life much easier when it comes to purging. So, all right, that's partitioning. I guess let me check the Q&A real quick. Oh, that is an excellent question, Rick. And I'm going to come back to yours. DT asked a question about data compression, so we're going to look at that when we get to that demo. But Rick asked, will RCSI resolve the necessity to include with no lock when performing queries in Sprox? Yes, it will. That's the idea, is that I should not use no lock. What it will not do is fix your code for you, right? So in that example that we were looking at, when we were looking at RCSI was turned on, and we went back and we, in read committed, were able to query the data and see the correct data. If I had run the read uncommitted query there, I would have seen the dirty data, right? So it's kind of a two-step process. One is turning on RCSI. Two is going and cleaning up all of your code. I noticed that in one of the sessions, I can't remember if it was today or tomorrow or when, that was one of the topics was, I believe it was Mala who was doing it, was using, I can't remember exactly, but that was one of the things it talked about, was cleaning up your code base, getting rid of things like no lock, right? So, there you go. Partition views versus partition tables. Partition views are kind of a poor man's partitioning for the most part. I haven't used partition views since partitioning became a first-class citizen in SQL Server. There are some performance use cases for partition views still, but I would, you know, partition view is basically, you know, we used to do this years ago, right? In SQL 2000 even, right? Where we basically would say, I'm going to create, you know, customer transactions 2021-01, customer transactions 2021-02, right? A table for each time period, union them all in a partition view and use the data that way. And so it's kind of a manual way of doing that. So great questions. And then Jeff mentioned a note that he left in the chat about using partition views for backups. So maybe we'll come back to that if we have a little bit extra time at the end. So, all right, let's move on to data compression, and then we'll come back and we're going to look at the actual CPU hit in these particular queries. To answer that question, it actually, you know, it's definitely one of those it depends things, right? Because it depends on the query, right? but in general, in most cases, if you're getting a good bang for your buck with your compression, the benefits you get from reduced I/O are going to trump the CPU hit. Now, you may have a CPU bound system, and you're going to want to think about that. So let's talk about data compression for a minute. We'll just stick in the demos. There's two different types of data compression that we talk about in SQL Server. For years, we've had page and row compression, which are just an attribute of an index. You're saying, hey, I want this index to be compressed. Page is typically more common, and it's basically page. It's going to remove duplicates on, that's how compression works, right? It looks for duplicate values, right? Within a page. ColumnStore indexes are also basically a data compression technique, right? In ColumnStore is exactly what it sounds like, right? We're going to take across a column, and we're going to look for duplicate values and only store one of those, right? That's what we're compressing, is across all the values in a column. And if you think about that, the reason ColumnStore is so fast and works so well when you're using it is because the very nature of databases means that that's going to be common, right? If you have a halfway decently designed database, you're going to have a ton of duplicated data across rows in a column, right? Even if it's just a foreign key, right? You've got, your cardinality tends to be pretty low for a foreign key, right? And so you get a lot of benefit out of that. Now, talk about all that and say, well, then why don't we just compress everything, right? And the answer is, of course, everything has a cost to it. There is a CPU hit to compress and decompress, and all data is not necessarily going to benefit from that, depending upon the nature of the data. So what we do, and Microsoft even provided this to us, there's a system store procedure called estimate data compression savings that will tell you, hey, for this table, even for this particular index, for page compression or row compression, what's that going to look like for me? So let's take a look at this. In worldwide importers, again, there's a bunch of tables that are already, or indexes that are already using various types of compression. There's one that's, it has page compression, there's a column store, there's a row, right? So there's a few of them in there. So what we're going to do is pick a table that does not have any compression. And actually, I picked this table on purpose because this table actually has a column store index on it already. So it's this sales.invoice lines table. And it has, just typical normal indexes, but it does have this one non-clustered column store. So that's the table that we're going to work with. I'm going to turn on my stats IO and stats time so that we can see the reads, and writes and CPU, right? And then I am going to make sure that this index is not compressed by rebuilding it. And I'm going to disable the column store index, right? So I've basically taken the column store out of the equation, and we're going to take a look at this query. Now, I'm cheating a little bit here. This query that I'm using in this demo happens to be the exact columns of this column store index, right? And what we're going to do is we're going to walk through that query, and we're going to look at it without any data compression, with page, with row, and with column store, right? To see what the impact is. So if I look at good old-fashioned SP space use for this table, we can see there's 675,000 rows, about 117 meg or so of data, and 29 meg of index, right? And let's go ahead and run that query. Let me make sure I have my execution plan. I do. And if we look at that, it's a clustered index scan on that primary key index, clustered index, right? It's, you know, there's our rows. One of the things that I want to point out is in the execution plan is the estimated IO cost, right? Because that's one of the things that we can look at as we go through these different versions, which was what, 10.8, almost 11 as the cost. And of course, all of this stuff is relative, right? So IO is 10.88, CPU is 0.74, right? All right, so now I'm going to take that clustered index and I'm going to rebuild it. And all it is a rebuild, partition equals all, data compression equals page. And that completed. Oh, you know what? I forgot to look at the IO. So we looked at it from the execution plan. So let's turn that off. Let's run this query again without compression. And we can see I had 14,700 logical reads, nothing else really as far as, you know, read aheads or wobs or whatnot. Okay, but so those are my logical reads. Logical reads versus physical reads, memory, disk, right? Regardless of whether it's coming from memory or disk, the more I can reduce my logical reads, the faster everything's going to be, right? We also see the execution time. One of the things, if you haven't seen it, by the way, if you take your output from stats.io and stats time, there's a really cool site called Stats Parser. Is it statsparser.org? Nope. Statisticsparser.com. You can paste that output right here and hit parse, and it actually shows you in a more friendly manner, I guess, what that output is, right? So what we're going to do, I'm going to leave that open and we'll just open a new tab and we'll look at it for these different queries, right? So 14,000 logical reads, and you know, there's our parse and compile and execute CPU times, right? All right, so coming back to this guy, now we'll go ahead and compress our index. And we could do the other indexes as well, right? Because in my estimate data compression savings, I actually used all indexes. But we'll go ahead and that's the only index we're using, right? So if we go back to space used, right, we're down to 42 megabytes of data, 28 megabytes of index. So that's well less than 50% of where we were at before page compression, right? To run our exact same query, we're going to get the exact same execution plan, right? We haven't changed the index at all. We've just made it so that more data fits on a page. So if we look at the execution plan, it's still this clustered index scan, but my estimated IO cost is now 3.9 down from 10.8. My CPU cost in this case is almost identical. So very little impact, right? If I take my IO, we can see the reads are down to 5,200 from 14,000. We do have some read aheads, and we can see the CPU. So let's go back over to Stats Parser. Let me move my zoom here, right? And I'm going to just go with this one. Oops. Grab that again. Parse that one. So we can see over here, we were at 14,723 logical reads, 5,200 logical reads. CPU went from, you know, what we basically 328 milliseconds to 735 milliseconds, right? So it does have an impact on CPU, right? But for most queries, CPU is not the issue. IO is the issue, right? So with page compression, we went down to almost a third of the logical reads, okay? All right, well, let's take a look at this with row compression. So we're back to our original table size, 117 and 28. And if we run our estimate specifying row, it kind of tells us, you know, what we think we can get. This step right here is probably one of the most important things that you can do when deciding what to compress and if it's worth it or not. And not just once, like this needs to be an ongoing or something that you recheck, right? Data changes, right? It's just like indexes, right? Most databases, we can't figure out the optimal index one time and forget about it, right? All right, so now what we're going to do is we're going to use row compression. We'll execute our exact same query. And one of the things that this illustrates, by the way, you know, the execution plan has not changed at all, at least the shape of the plan. The values have, right? The estimated IO cost and so forth. You know, one of the things that I really like to point out when looking at query performance, you know, step one is you have to look at the execution plan, right? If all you're looking at is your T-SQL code, you're getting a very small part of the picture. But you really have to look at these values, whether it's through the execution plan showing the values or through stats.io, right? What we can see, we're at 7,600 logical, 277 physical on this one, right? So not quite as good as page, but still a heck of a lot better than what we got without any compression at all. And then of course our CPU time will be similar. It's probably going to be a little bit higher because there's more decompression to do, right? So if I go, let me grab another new tab. Why do I keep doing that? Try that. Right, so there's our you know, logical and physical. And there's our CPU, right? So our CPU is at, you know, 500. That's interesting. It was actually a little bit less on this one than it was on the page. And then of course the lowest was on the uncompressed, right? So this statistics parser site is really cool. I had a coworker show that to me just like a month ago, and I was like, wow, that's really, really helpful. All right, so now let's bring out the big guns and use the ColumnStore index, right? So a couple things on ColumnStore. ColumnStore is newer than, you know, some of these others. And when ColumnStore first came out, they were read-only, right? So this was really an analytical workload thing. But we now have the ability to create a non-clustered ColumnStore index that is updatable, right? So let's take a look at that guy. So what I'm going to do is rebuild that index. That's how you enable a disabled index. And let's run the query again and see what we get. This time, we got a different execution plan. Makes sense, right? Because we're using a different index, right? The ColumnStore index, right? It's still a scan. That's okay. But it's still, if you look at that estimated IO cost, 0.26. And you know, the IO, you have to look at a little bit differently for ColumnStore, because if I look at my invoice lines table, it says, wow, 0 logical reads. Well, what you actually get are logical reads. under the hood, ColumnStore data is stored as logs, right? So large objects that they're not stored in the table, right, is the best way to put that. So that's where we had to go to get that data. But it was 1,200 versus 5,000 on the page compression, which was our best value, right? So, and we can do the same thing here with stats parser. I'm just going to go and reuse one of these, if it will cave. So on this one, we can see, you know, really did not like stats parser apparently has not been updated for ColumnStore because it didn't like some of that. Anyway, you get the idea, right? We saw going from, what was it, like 15,000 or something like that? What was the original? Almost 15,000 logical reads to around 7,000 with row-based compression, 5,000 with page-based compression, down to like 1,200 with ColumnStore, right? So again, this is a feature that since 2016 SP1 has been available in every SQL Server database, right? Not just enterprise, right? So this is one that, you know, you can implement. And what's nice about this compared to like RCSI is that, you know, you can start using this judiciously, right? RCSI, you're going to turn on for an entire database, right? And so then some of the, you know, the things about, well, how many writes do we have and how's that going to impact TempDB and what does that look like can be concerning. This is one that you can, you know, just choose some indexes that have high value and rebuild those indexes with compression and see that impact. So let's take a look at the Q&A. That's the chat. Someone did point out that, yeah, only 2 physical reads on the one query. So the question was, presumably change in estimated cost may change selected plan in some instance. Absolutely, right? So, you know, as you're doing this, you know, you're going to need to look at your plans. You know, statistics are just as important here. And there's some caveats around statistics with ColumnStore. In terms of an OLTP database, I would be very comfortable being pretty aggressive with row store based compression, which is, you know, page and row. ColumnStore absolutely can benefit you. The other thing that ColumnStore does for you is that for some queries, not all, it allows the query execution, part of intelligent query processing that we've heard a lot about over the last couple of years, to use what's called batch mode processing instead of row mode processing, where it's going to be reading data batches at a time. And so, but the answer to that question is yes. With anytime you're, you know, making changes like this, it's going to impact your execution plans. So, which is interesting that you bring that up, because one of the things we have in this database is that query store is enabled. And we've been running a bunch of these queries that would have some differences in execution plan and in other performance characteristics. And we should be able to see those in query store, which is where we're headed next. All right, query store. So a little bit of history here, right? One of the things that, you know, we've kind of always had, well, a couple things. In terms of built-in, you know, telemetry, metrics, whatever you want to call it, SQL Server, in terms of what's going on right now, prior to Query Store, there hasn't been a lot of available to us out of the box, right? Now, you have like Activity Monitor where you can see some things that are going on. You have, you know, SSMS has some built-in canned reports that, you know, pull some things out of the plan cache. You have things like, you know, Brent Ozar's first responder kit, you know, SP Blitz cache, but pretty much it was kind of heavy lifting for the DBA to go see what's going on, right? And that's where tools came in, right? And so you have, a lot of fantastic, purpose-built database monitoring tools out there. Things like, and I don't want to exclude anybody, but the big ones I think of: SQL Sentry, SolarWinds DPA, Redgate SQL Monitor, Quest has a few products, Spotlight, and so forth, right? But they're all kind of doing that same thing in capturing queries and allowing you to see what's going on, right? QueryStore was developed by Microsoft initially in the Azure SQL DB PaaS product. And Azure SQL DB has a bunch of stuff around automatic tuning, right? QueryStore is the engine underneath that, right? And so they said, hey, let's add it to SQL Server on-prem, right? So there's quite a few features that are that way, right? I think, is it Service Broker that was actually built as part of mirroring or something like that? And they said, hey, we can make it a feature, right? And so that's where QueryStore comes from. QueryStore is configured on a per database level, which is good and bad. It's good in that it's a property of the database. So if you have it configured, you restore the database somewhere else, it's just there, right? Like anything else that's a database level setting. The bad part is, not bad, but just something that we can't do yet, is in an availability group. If you're using read-only replicas, well, the QueryStore on those read-only replicas is read-only, and therefore is not valid for that replica, right? So there's no QueryStore that's tracking your reporting queries or things that are happening on that read-only replica. That's actually changing in 2022, a writable QueryStore for read-only replicas. One of the things, I haven't had a chance to play with it yet, but then I plan to. So the way QueryStore works, and this is one, possibly even more so than RCSI, it blows my mind how many 2016 or higher servers I see that QueryStore has not been enabled. It does have some overhead, right? But it's pretty minimal and it's controllable. The way it works, if you look at the database properties, and you go to the QueryStore tab, there's a few things that you configure here. The statistics collection interval is normally 15 minutes by default. I've dialed that down for demo purposes. The interval for flushing data to disk, how many plans per query, the max size of your QueryStore. If you have a busy system, one of the things that will happen is if your QueryStore fills up, it will flip from read-write to read-only, meaning there's no new queries being added to that. And so that's one of the things that you just kind of watch for, right? It also points out though that, QueryStore is not going to take down your system, right? Because you can control what that looks like, right? So there's a few things here, right? And, when you go to implement this, there's some best practices around that. But ultimately what it is doing is it's capturing queries, right? It also tells you here, how big is your database and how big is the QueryStore, right? So we're at, 24 megs. You can purge query data, you can control those things and so forth. Once it's enabled, we have, as a first-class citizen in Management Studio, there's a folder under the database called QueryStore. And there's a bunch of just kind of built-in reports, as it were. We're probably not going to see anything on regressed queries. We'll take a look. We do have some things. Okay. So what I'm looking at here, it's a top 25. Obviously, this is a demo system. There's not a lot of activity, but we will be able to see the activity that we've generated over the last hour, right? And what I'm looking at here is by duration, and I can say, do I want to look at the average, min, max, total, whatever, right? I can also hit configure over here And, you know, what am I interested in? Is it duration, CPU time, reads, writes, row counts, right? Lots of different things that I can look at here. Weights, and then what's the time interval? Last hour, last week. I'm going to go to like the last 12. We'll leave it in the last hour. We've generated some activity at least, right? And that's what we have. And then what we have here, there's, for every query that executes, even if you're looking at the plan cache, right? You're going to see the same things, right? You have queries, or, you know, in DMV parlance, that would be the SQL text, right? Or the hash of the SQL text, right? Here it's a query ID, and they just identify that query by a number in the query store. So this query ID is 42152. But each query could have more than one plan, right? And so when I choose this query here, it gives me the query and the execution plan down here, and they can see the actual execution plan. One of the really cool things about this versus the plan cache, right? Because it's capturing, you know, each execution. And then over here, I can see the plans that I have, right? Well, if we know what this query is, we've been looking at it for the last, you know, 45 minutes, whatever it's been, right? We can guess what these queries are, these plans are, right? With and without ColumnStore, right? So if we look at that, if I look at 543, which, notice it makes sense, right? Here's the, you know, total. Now, keep in mind, we're looking at the total. If we look at the average duration, right? So we're what, like 3.5 seconds, something like that for this version. And if we look at this guy, we get the execution plan that says it's a ColumnStore, and this is what it looks like, right? So we can see right there that, wow, I really need to be using that ColumnStore query. And we can do cool things like we can say, you know what, I'm going to force this. So this is not just reporting, telling you what's happening. You can actually control what's happening, right? If you have a plan that, you know, that's your preferred plan, you can actually force that plan. Which force may be too strong of a word. You're strongly suggesting that that's the plan that you want to use. Like so many things with plans that, you know, or hints, you know, that it's not ever going to be a guarantee, right? So that's one way you can just look at queries. They're called regressed queries, meaning that these values are changing, right? Whether it's the duration, CPU time, right? We should be able to see that here too. That one is going to be the opposite, right? CPU time for the ColumnStore query is way up here. CPU time for the other query is way down here, right? Our logical reads, we're going to see the exact same thing, ColumnStore, right? So, and that's just one query, right? And we've got some other here, that's a stats. Yeah, that's my query that, you know, when we were looking at the rows per year in that customer transactions table, you can see I only had one execution plan, but I can see all those values, right? I can look at overall resource consumption, right? So if we go to, you know, and again, we have the same things in terms of, you know, what we want to look at, execution count, the time interval, and so forth, and we can see that, right? And of course, I can, you know, see what's going on there. Top resource consuming queries, right? So we can see what's kind of cool here is that here is this 543, but we can see kind of each execution, right? Because those aren't always going to be the same, right? So it's a really powerful tool to see what's going on your server. That's free. It's part of SQL Server since 2016. So weight stats is another one, right? Based upon total weight or average weight. And then we can say, it makes sense, you know, async network IO is going to be the most expensive thing we've been doing because we've been pulling 675,000 rows multiple times, right? But maybe I want to look at, like, you know, parallelism, right? And what do we have? And of course, we don't have anything very good there. But if we look at that async network IO, it actually tells me the queries that are contributing to that weight type. And then finally, you can take a query and say, I want to track that query over time, right? So this is a problematic query. Maybe we've done some stuff with stats, maybe we've optimized it, maybe we've done some indexing, whatever, and we just kind of want to, you know, track that over time. So query store, another, you know, really important. And again, I bet 90% of SQL 2016 databases that we look at are not using query store. And I think it's just because people don't know or you know, I named the session feature phobia for a reason, right? That a lot of these things are new. We haven't used them before. You know, we're not sure what the impact is. We've, you know, query store, maybe we've had an experience in the past with monitoring or you know, someone, you know, with profiler, you know, capturing execution data and causing performance issues or even an outage. And so we're really hesitant to implement anything like this. But these are, you know, important things to be looking at. So those were our demos. You know, we've got what, about another 10, 15 minutes. So happy to, you know, take questions, discuss these things. Obviously, you know, we looked at 4 things, right? Out of, you know, what, a list of 20 or so, right? And so not a deep dive into any of them, but hopefully gets you thinking about, you know, in your environment, you know, how you could go about using these features. You know, socialize the common programming surface area, right? That's one that not a lot of people seem to be aware of, that, you know, we have a lot of people have been doing SQL Server for a long time. Oh, I'd love to use partitioning, but that's enterprise. Oh, wow, page compression, that would be great, but that's enterprise. Well, it used to be only enterprise. And so just, you know, be aware of it. Always take a data-driven approach, right? You know, run your estimate data compression savings, and, you know, in a sandbox environment, go, you know, build some of those indexes and look at that IO. And that's how you say, hey, this would really benefit. And then the last thing is SQL Server is not cheap, right? This is a very expensive product. So let's use it, right? And sometimes that becomes really a back and forth with developers, right? I just one quick kind of, you know, somewhat related war story from just the last couple of weeks. Did a scalability assessment on a very large OLTP environment, 4 terabytes of RAM, 64 CPUs, and about 25 terabytes of data, right? Something like, you know, around 15,000 transactions per second, right? So a big dog, right? A really big database. The number one wait type on that instance, async network IO. Async network IO is when SQL Server is sending data to the client faster than the client can consume it. And so SQL Server is just sitting here and saying, hey, I'm waiting for you to receive this to act. It's a TCP acknowledgement, right? Well, it turns out in this database, there was a column storing XML, not as an XML data type, as varchar, so no indexing, of course. XML indexes are another story from a performance standpoint, but they have their place. But the point is, they were pulling megabytes of data out of these XML columns to the app server every time they needed anything out of that XML, shredding the data to get that maybe one value, one scalar value out of that, right? And, you know, we can talk about data modeling and XML and databases and all that, but if all they did was an XML index that would allow them to query that value out of the XML and just send that, you know, that would have a huge benefit, right? That's, you know, and that's a feat. XML in SQL Server has been around for a very, very long time, right? So there's all kinds of things like this that, you know, let's use SQL Server for what it's good at. So, all right, let's check the Q&A if there is anything new. I'm not seeing partition view. We talked about partitioning to save in a major way on backups. We can talk about that a little bit. I didn't read what you said, Jeff, but I imagine it's, you know, not having to back up the portions of the data that don't change is what my guess would be. And so, you know, that's a big one. So that's what I have for you today. You know, my contact information in terms of social media was on that first slide. So if there's, you know, any further questions or things that you might have about any of these topics or just features in general, right? You know, I'm happy to hear from you. So any other questions, chat, anything else? I'll stick around for a few minutes here.
There's one real quick in there, if there's comparable indexing on JSON data.
There is not. So one of the things that Microsoft did when they implemented JSON is there's not a JSON data type, and thus there's no JSON indexing. What we do have are JSON functions, right? So that if you store JSON, you can you know, query it and parse it and things like that. But no, you know, I don't know the reasoning behind that, but even so, still that's a great example, right? Like rather than querying that entire JSON document and pulling it to an app server across the network, you know, use the JSON functions that we have available to us. So XML indexes, you know, that years ago I used to do a session on XML and XML indexing, and you know, there's some definite caveats around using XML indexing. So in general, I'm not an advocate of storing XML in the database. If it's data that you're going to query and that you need, normalize it, right? But in that particular use case, it was like, hey, if this was even just stored with an XML index so that you could query the data on the server, that would be helpful. So.
Yeah, it seems like you've covered most of it. It's
slowed
down to a very trickle question-wise.
Yeah, well, this was good though. You know, whenever you're doing virtual conferences like this, sometimes the interactivity with you know, with the participants, you know, people just don't say a lot or ask questions. So I love that, you know, we had an engaged crowd that were asking some great questions. So
absolutely. Phew. Thank you.
All right. Well, last session of the day and 8 minutes to spare. So I doubt anybody will complain about that. So and thanks to everyone who puts on GroupBy, right? You know, free conference. I know, you know, Blythe and her team work hard on this, and volunteers, and so it's great to be part of it.